Welcome everybody. Sorry for the slight delay. Paul is usually the wizard that gets the audio recording set up. He delegated the duty to me today so he can test the bright young minds of the University of Waterloo Computer Science program. And it's set up. But I appreciate all the work that he does even more so than I did before. All right, so this is KW Love, Kitchen to Waterloo Linux Users Group. We meet the first Monday of every month and bump the holiday Monday. Happy October, welcome to the fall. Thank you for braving the slightly drizzly, dark weather outside. We've got a presentation from our, regular presenter, Callan, who's going to do some microcontrollers, Internet of Things. He's done several other presentations on Arduino kind of microcontroller stuff before, and it's always been good, so I'm looking forward to it. Now, he's telling me
other people did Arduino, not me.
Maybe I could be wrong.
Well, your son did one, didn't he?
Yes.
What's
And
that?
your son did one on the Raspberry Pi, didn't he?
He was a son of a friend, but
Oh,
yeah.
You can take credit for that. You made it happen. So that's for tonight. Other things for tonight, there's a bathroom in the back. We want to thank the space, which is the KW Innovation Center, also called the Spur. They make the space available to us for free if you are looking for office space or a hot desky thing that you need to set up your business. They are available. Lots of nice people are already here. That was it. We have coming up next month, November, we are going to be doing some security stuff. Mark Steffen and Jim Kelch are going to be doing some Linux virtualization to start up as the beginner section. And then Mark is going to talk about some compromise detection tools, all open source stuff as far as I know. Then in December, we're going to go back to the well for containers. We're going to do some LXD stuff. So this is the sort of the underlying technology in Linux of all the containerization stuff that everybody else does. So this is kind of what, if you use Docker, it's what Docker does underneath. So that'll be great. I think we are potentially looking for one more presenter for December. So if you've got a beginner talk that you wanted to give, whatever the topic was, you'd be welcome to come back. And otherwise, we're looking for presentations for January onward. So if you've got something that you want to talk about, I'll pass around the attendance sheet. So you can join the mailing list. You can drop a message there. You can come talk to me. You can come talk to Paul at a future meeting. If you have a topic that you want, again, you could drop a message on the mailing list. You could put your hand up right now. No, that never happens. That makes sense. Oh wait, Tim's gonna jinx my prediction.
This was an idea, I think we talked about this last time.
Oh, yes.
So how the internet works is a recurrent thing that people come to us, saying. And I was gonna eat the whole elephant all at once, and then I realized I could be lazy and not. And so we had considered an idea of breaking it up into kind of basic components, like talking about routing, talking about IP addressing, and breaking it down into these subcomponents, and then giving lightning talks. So everybody would have a 5-minute lightning talk to talk about a very narrow, specific topping. Yes, topping. I'm thinking of cupcakes. Topic related to how the internet works. And so, what do people think about that? And then, to add on to that, we'll need to come up with that topic list so people can take on those topics.
Mm-hmm.
I think if anything, if we were going to do something like that, everybody would have to pre-send us the slides and we'd have them just on a central machine.
Yeah, oh, absolutely. Yeah. Slides would have to be condensed ahead of time. We could agree that, we will have a shared Google slide deck, say,
Sure.
and then we can play them off that or something like that.
Yeah. So you know what we should do? We should probably, because when we talked about this before, we started to sort of brainstorm what the topics might be.
Yeah.
So I wonder if we should start putting something on the mailing list and just start a list of like, okay, here's the the 5-10 minute chunks that someone would take.
I can do that, because I was originally gonna give the whole talk, so, I mean, somebody can just make that decision, and then we can argue about my suggestion. And that way we're not leading by committee, we're leading by like, here's something that's functional, and then we'll move it in a direction the group likes.
Yeah.
Why don't we use the GitLab Kanban?
Oh,
And then you can
fancy.
have a little 5-minute section or whatever minute section
Yeah.
we're gonna do, and then we can shuffle around that
Yeah,
list.
we'll give that a try. Go play with
Yep.
GitLab, another good open source product. All right. Other things. The only event that I know of is coming up. I saw the Toronto Security Conference is happening this week. I think it's not particularly open sourcey, but interesting. StarCon is coming up at the beginning of January. I think the request for papers is closed, but presumably their tickets will be opening up soon. They ran last year, and there's been lots of good free software topics there. And I think that's the only things that I know. Nobody did a free software day thing today, or this year. This would have been September would have been free software day, so maybe next year. But all right. So the last thing is after Khaled's finished, a bunch of us will usually go out for dinner. We've gone to the Tannery building at the food on Taste of the Tannery. Thank you. I cannot remember the name of that restaurant. So Taste of the Tannery. So can I get a show of hands of people who are planning to go? All right. So if you'd like to come along, everyone is welcome. Follow one of those people or use your own personal knowledge of the city, and we'll see each other. We'll see everybody there. But before that, I was going to tell us some Internet of Things thing. Thank you very much, Cal.
So one thing I forgot to put on is an introduction to myself, but I see a lot of familiar faces here, so those who know me, okay, can raise their hand.
Not sure about this.
One time
So-
I decided not to do an intro because everybody's always had their own introduction in their slides.
Okay, so basically my name is Khaled. It's spelled with an I, so here in North America it's Khalid for some reason, which kind of hurts me off. But basically my education is a pharmacist, but then I switched to software. I programmed mainframes and mini computers for many years, and then I went into consulting, and then I skipped the whole corporate thing and did open source development. So I'm an open source developer. I write software for the web, and this is just a hobby. This microcontrollers thing started with a hobby at home, and then it kind of branched itself into the open source world, as I'll tell you how. But yeah, so I've been around software for a long time, 30 plus years, 32 years now, I think, and most of it is computers, and that's why I'll be talking about the Internet of Things, okay? The microcontrollers versus computers, the Arduino and the Arduino IDE, and then two microcontrollers by the name of ESP8266 and ESP32, MicroPython, which is a Python distribution for microcontrollers. I'll talk about Home Assistant, a very brief overview. I'm not covering the whole topic because it's a huge thing, but I'll see how I tie microcontrollers into it. And then there is an ARM Cortex CPU that I've been using as well, and we'll give an overview of the projects I've been using. So, what is the Internet of Things? It means different things for different people. Basically, it can be scary, and you can say that oh, the fridge will order eggs automatically when it's out of eggs, and that means that whoever owns whoever makes the fridge will probably have a database on you and your consumption habits and all that, and we all know that data about you stored anywhere is not a good thing. Okay? Basically, people now are getting Alexa and getting whatever that Google Home thing and all that, but your data is there. Someone may hack it. The company may choose to use it in a way that you don't know how it is used. We've all seen the Facebook leak, and other companies in the news, the Equifax. Again, it's someone that has your data without you having a say that they collect your data. But when they ask you, do you want us to do a credit check? That means that everything goes there. But then someone hacks it, and a bad employee sells it. The company itself changes its tactics. The company is sold to someone else, whatever. So there is also, the direct hacks that, there are lots of security cameras from China, and someone was able to have I think, is it the Shodan search engine that you can go and search for cameras that are open, and then you can go into people's houses and look at them. Yeah?
Can we consider that self-driving cars are part of the Internet of Things?
Depending on, if you look at Tesla, then yes, you can lock your car remotely. They can, add features to it and stuff like that. Now, it's always a trade-off. Some people say, "Oh, I don't care. I'm not that interesting, and I don't care about my data being out." I use Google, for example, on my phone, and that by implication, they know where I've been with the maps, even though I turned that feature off. There was something in the news. But there is another side to the Internet of Things, okay, which is useful, like crop monitoring. So there are people who have acres and acres of land, and they want to monitor the soil. So if the soil is like below a certain kind of moisture, then they would turn on the irrigation system or something like that. Or when they want to harvest the crop, it has to be at a certain temperature or whatever. So they have these devices. And something else is a locally monitored alarm system. Now you have Rogers, for example, or Google, they have these security systems that are centrally monitored. They sell you on this cloud thing or whatever, but then you can also have something that you monitor and no one else knows what's going on. And this is what I'm doing. Also, it doesn't have to be TCP/IP. There is, for example, for this crop monitoring and these thing, there is a protocol called LoRa, which is long range. That's what it stands for. It's not a free protocol. It's owned by someone and subject to copyright, so it's not like ubiquitous in everything like Ethernet or whatever. But it's there. It's out there, and there are devices that are reasonable. You can get a device for, I think, $7 that would interface your microcontroller to LoRa, if you have that need. So, what's a microcontroller? I'm someone who came out from computers, okay? So there are computers, there is systems on chips. So the Raspberry Pi is a computer because it has peripherals. You can connect it to a display. It has USB where you can connect devices to it. You can put a keyboard or a mouse. So input devices. It has an operating system. It can do scheduling and multitasking. And there is a command line shell that you can go in and write scripts that will do things for you. So when I talked about the Raspberry Pi before, even though it's a sort of an embedded system, it's not a microcontroller. Microcontroller doesn't have any of that. Okay? Basically, it doesn't have a file system even. And the program is stored in EEPROM, so there is a chip on the microcontroller, or it's sometimes inside the big chip in there that stores the program, and that's it. And normally it's like 128K or 512K, and it's a limited amount of storage. And the program would start, do some initializations, and just keep going in a loop. For example, if I want the temperature sensors, then I will have a microcontroller and the temperature sensor connected to it in a certain way, and then I have a program that would say, start up, initialize the sensor, and then read the temperature, and then do something with it. Either send it over the network or log it into on a certain thing or something. But that's it. And then keep doing this over and over and over and over again. There is no concept of multitasking. There is no concept of user accounts. There is no concept of security. None of that is there. It has GPIO pins, and that's how the microcontroller talks to the world. So, in effect, an ARM CPU is a microcontroller. It has pins, and each pin has a certain restrictions on it, the amount of current that can go on it, the type of, is it analog or digital, what you can program it for, etc. And before the revolution of the Arduino, it used to be that to program microcontrollers, you had to have custom hardware, like JTAG and other stuff. and usually it's sometimes specific to the manufacturer. So if you're programming an STM32 microcontroller, then you have to get something called an ST-Link. So a device from them that talks their own protocol, and you have their own stack. So you'd have programs on Windows that would talk to this device, and the compiler is specific for this, and you normally paid for an SDK. And it was like a big hurdle for you to program microcontrollers. So unless you're using it for commercially for something that you're going to sell, a device that you're going to sell or something, it wasn't worth it doing it at home. It was hard to debug. There's no user interface, so how can you debug stuff? But around us, everything is controlled. The world has lots of microcontrollers everywhere. So there is your thermostat at home is a microcontroller. It has a temperature sensor, and then it will kick the heating or cooling depending on how you set it up for a certain amount of time, and then stop, okay, so as not to overload the compressor or whatever the device is, and then we'll keep doing this stuff on forever. Your oven at home, so your range is the same thing. It has PWM, which is pulse width modulation. So when you set you're heating say you're doing a stew or something, and you set it on medium. So you will see that it will turn on and then turn off, turn on and then off. The time intervals of turning on and turning off is called pulse width modulation. So it does that based on the temperature and all that. The water softener is the same thing. Turns itself on at a certain amount of the day, does its cycle, and then stops. Okay. So then Arduino came along. So this has been more than 12 years now or something like that. Arduino came out. It's basically so it has GPIO pins. So here are the pins, analog pins, and then there are some digital pins here. You can power it from 12 volt or 8 volt or 9 volt power supply. This is a power regulator here. This is the microcontroller itself, but someone put in a board and made it open source, so the hardware is open source. And there was a split in the people who made it, and there was a huge lawsuits and stuff like that. But now they are reconciled, and it's back to one community, one thing. So you connect your stuff to these pins. You put power here. You write your program somehow, and then this would run and keep doing the stuff. There is USB, so this is how you program it. So you flash it. We call it flash it. So basically, flash is basically loading the program. Okay. And then a few other stuff here that's not important for you to know what it is when you program. There is a whole ecosystem of shields around it. The shield is basically something that has the same footprint as these pins and plugs on top of that board. So there is a motor, shield. There's an Ethernet shield. There is a whole bunch of shields, sensor shields, and all that. And then some people make their own shields. So they get a piece of perf board and they cut it, same thing, put female pins on it, and they plug it in here, and then they put their own sensors on. So you can do that. You can get clones from China for around $9, so it's not particularly expensive. However, it is relatively slow, 16 megahertz. Okay, it has very limited RAM, 2K. Okay? Flash storage limited to 32K. It's largest size. It's like fits in the palm of your hand, so it's not particularly small. But there are smaller variants. There is Arduino Nano, Arduino Micro, and stuff like that. But then there is the Arduino IDE, and this is where the value is really. So it's an open source software. It's free, you download it for free, so there is no more paying for the SDK. And because the devices have USB in them, you don't need special hardware. Okay? It's a Java application, the front end to the compiler and linker. It's basically C and C++. So there is still some kind of computer science knowledge that is needed. So if not everyone is amenable to programming in C. But since the programs are typically they are small, they're not big, C is not like a big hurdle, but still you can have to, yeah.
I've seen people program Arduinos with Sketch as well.
Actually, with Arduino, the C program is called Sketch.
Okay.
So they try to dumb it down and not talk C. So they said here is a sketch, and instead of calling it .c or .cpp, they call it .ino, .ino.
Sure.
Okay, but it's actually C inside. So if you know C, so it's C but plus some libraries and specific conventions that you use, and you're done. It's not particularly hard, especially if you've done C, you know this stuff. Okay, you there is a learning curve. Yes.
So if I go buy like a Raspberry Pi for, I don't know, $10 or whatever,
Yeah.
why should I bother?
Okay, the Raspberry Pi is a different thing. The Raspberry Pi, you normally run it with the Linux operating system. Sometimes you need something that is smaller and more specific to the task. Okay, so you need something that can go in a very tiny thing. Okay, I'll show you what we did with the project. So, I mean, if you know Linux, then it's second nature to go for Raspberry Pi, and I did that already. The Home Assistant that I have here runs on a Raspberry Pi. Okay, if you want to interface to the cloud and publish your stuff online, maybe you also need that, but you don't have to. Okay, you may in your house you may have a door sensor, a window sensor, and then say humidity sensor in the basement or smoke detector or something, and all these interface to a Pi. And that's where the Pi would take the inputs from these things. So the Internet of Things, these are the things. Okay, the door sensor. So the door sensor will tell you if the door is open or closed. Okay, when was it open? When was it closed? The sensor itself doesn't keep time. It doesn't know what the clock is or a time or a date, but it sends to the central computer, in this case a Raspberry Pi, and it will log these things. Okay, so we'll come to a diagram and it will put things together later. So when you use the Arduino IDE, you have something like a serial monitor. So basically you open a screen and you can display stuff to the serial. So there is a command called serial print, okay? And you send that stuff, and whatever you put there will appear on that. So that's a way for debugging, and that's a way for display as well. It's not a user interface when you have the sensor decoupled from your PC and hanging on the wall somewhere. Okay. They have a support for a wide range of boards, so they are not limited to Arduino. So the Arduino IDE can be used for STM32, the ESP8266, the ESP32, and a whole bunch of array of stuff. So you're not limited to the Arduino, and it became its own ecosystem, which is really nice. And there is libraries galore. You want a library that supports this sensor, you have it. You want a library that does real-time clock, you have that too, etc., etc. So that's why I call it the amateur microcontroller revolution. Okay, this is when any amateur can buy cheap stuff and start programming things without sinking in $500 for the SDK and whatever the cost of the microcontroller is. And in the previous days, you used to say, okay, so the microcontroller is $5, but the minimum order is of 100. So 100 times 5 is a significant investment, but you only need 3. What do you do? Okay, there are ways around that which will be mentioned at the end. Okay, so I'll tell you of a few things. So for example, this is called the STM32 Blue Pill. Okay, they call it the Blue Pill because there was a red version before, and someone asked in a forum, red pill or blue pill, and it stuck. So there is the Blue Pill. And it's basically, it runs much faster than the Arduino, 4.5 times faster, 72 megahertz. It's 20K of RAM, so 10 times the RAM, and 4 times the flash size. And it has a small footprint. Okay, I'll show you how small it is. It's this piece in here. So as big as one of my fingers. No, 2 fingers say. Okay, it's inside. So another thing is that some of the devices are 3 volt only, some of the devices are 5 volt only, some of the devices can tolerate both. So depending on what sensors you're using, okay, you would be limited by one or the other. Okay, so this one has one side, okay, no. So one side is 5 volt tolerant, the other side is not. So you have to be careful where you connect what where. It has a flimsy micro USB. So one of the advice is that you put some pieces of solder on in here, okay, to make it more sturdy, because you'll be plugging it in tens of times while you're programming it until you get it working. But it's cheap, $3. Really cheap for that footprint, for that speed, for that amount. It's really good. But there is something that's better. So for the same price, there is the BlackBerry. Same MCU here, okay, but it has a better sturdy micro USB. Okay, it already comes with that. But then it's only 3.3 volt. So if you have sensors that don't work with 3.3 volt, you cannot use this. Okay, but if your sensors are work with either, then you're okay. Then there is the ESP8266. So this is basically was a Wi-Fi add-on boards for Arduino. So someone came up with it. It came to the attention of the Western world in 2014, but it seems to have been popular in China for a few years before that. There are some Russian forums that buy these devices, they kind of etch the plastic on top of the MCU, and then they photograph it under a microscope and try to find out what it contains. So they came up and said, oh, this thing has a full RISC CPU. Let's use it as a CPU on its own. Okay, so they did that. And I have one here. So this is a temperature humidity sensor. So that's the sensor sticking out so that you can measure the temperature and humidity. Then the board is inside here. Okay? And it just plugs with the USB, and I have a phone charger to power it. So I'll put it under the couch and the return air intake, and it should measure what the house temperature is. Okay? And then there's a program inside that keeps measuring I think every 60 seconds. It will go in and do the measurement and send it to a Raspberry Pi. But the board itself is this is not the only ESP8266. There are various footprints, but you can see it's not much larger than the STM32. But that's just one variant. There are some that are smaller than that. There are some that are bigger. But it gives you an idea of what you can get. For example, there is 80 kilobytes of RAM, 512K, 24 megabytes of flash, depending on what variant it is. GPIO pins, not too many, usually. The modules there are various modules under these names, so you can buy any of these, and they will have this guy inside, but then they vary in the number of pins available. The Lua firmware, you can program with Lua. So there is the Node MCU especially was written with Lua firmware. There is the Arduino IDE, and then Microcontrollers. So you have options on what to program it with. Here's an example of a very small one. That's how big it is. Okay, but it only has. Yeah, it's as big as one knuckle. That's it. Okay, but it only has 2 GPIO pins. That's it. So it is used, but then it has a transmit and receive lines, so you can interface any microcontroller with it, and that's how you make your project Wi-Fi aware or Wi-Fi enabled rather. Okay, so that's how big it is. So you can see here is the chip itself. This is some auxiliary chip. I don't know what it is. And then if you touch up, here is the antenna, and that's the pins. So transmit, receive, power, ground, and then GPIO 1, GPIO 2, and the chip enable, and I can't remember what the additional one is. Because of the way the pins are adjacent to each other, it is not breadboardable. So there is an adapter that comes with it, small adapter like that can make it. You can put it on a breadboard. And Again, this is the one I showed you earlier, this one. It's actually, this one is a roll-in, this one is a Node MCU. They are very similar, but then you can see there are more GPIO pins here and here. But there are restrictions on what you can use each GPIO pins. On the STM32, there isn't much of a restriction on what you can use the pin for. But here there are. Okay? There is a USB connector here. The one before that, there is no USB connector. You have to connect it to a breadboard. And this one is about $5. The other one, $3. Okay. Then there is the bigger brother, which is the ESP32. So basically, it can run up to 240 megahertz, which is really high. It can have up to 16 megabytes of flash. Same thing about the GPIO pins. I don't know of any that are true, so there is no ESP version, so this is a mistake here. But there is a Node MCU 32S, LOLIN 32, etc. And again, you can program it with these things. Same thing. But then there is MicroPython, which is basically, there are some gray hairs here, like me, and you must have used in the 80s, used the computer that when you powered it on, had BASIC on it, right? Okay? So even DOS had BASIC, GW BASIC, and off you go, okay? Same thing here. You just plug it to USB, you have a Python prompt, and you can start programming away. So no compilation, no special stuff. Everything is in text. There is really nice environment. So it has something called the REPL. It's basically read, evaluate, print, loop, which in other words the command prompt. Okay, but actually it's a command through the same language, just like BASIC. Okay, so 10 print whatever, 20 go to 10. Okay, first program you write, and then Control C to go out of it. Originally this was written for two boards. One is called Pi board. A special board that is for the Wi-Fi, but these were expensive. They are still out there, but I think they are $35. But this one, the ESP32, can be bought for around $8, $9. So a big difference there for the price of you can buy 3 for the same price. And so the MicroPython was ported to these guys. And you have the low cost, but then you have built-in Wi-Fi, which is a really good feature there. So you can, and this is how I did. This is what I did with this guy. Read the temperature and humidity, calculate the dew point, send all this information to the Raspberry Pi. Okay, at the regular intervals, and then the Raspberry Pi can, if the temperature falls, then whatever, then email me or something. Okay.
So MicroPython comes with a keyboard and display?
Through the USB, so through a computer. So you connect this guy with the USB cable to the computer, and then from the computer you can run a terminal. I'll show you later. Okay, so these are the things that I started doing with the stuff that I told you about. So I want to do a solar powered weather station. So I wanted to have a power station that would be outside. It would measure so temperature, humidity, and barometer. And then if you wanted to add wind and rain, this would be moving parts because the rain has to fill for a while and then empty itself. And then the wind would have a this thing that rotates, okay, for the wind. So it was more complicated. But then I scrapped the idea not because of I don't have the wind gizmo, but basically because of weatherproofing. So I already bought the batteries, I already bought the charging board for it, I had the sensors and I had the microcontroller itself. But then I found that to make it really weatherproof, our weather here is so variable, something in the sun when it's 32 in the summer, and then that same thing would be in minus 20, and with the ice build up on it and stuff. I said probably I couldn't do it. So I just sold the parts that I don't need on Kijiji, and I ended up with programming the Raspberry Pi to retrieve the weather information from online services instead. but inside the house I have my own sensors. So that's the indoor temperature and humidity sensor. So DHT22 is one of the sensors that you can use. It does temperature and humidity. There's another one which is BME280, which adds a barometer to it. Okay, and I bought 2 of these, and while I was soldering the pin header, the pins on them, I said instead of doing it this way, I'll do it the other way, and so that the sensor will be exposed to measure more accurately away from the heat generated by the MCU. And I probably burned something, and 2 of them really died on me. So after testing them with, before soldering, they worked, okay, or one of them worked, and then when I soldered the 2 of them, they stopped working. But they're like, $3 each, so it's not a big deal. But then I abandoned the other sensor. And then I have a garage door sensor, which has the ESP32 as the microcontroller, the same DHT. So because it's in the garage, it will at least measure the temperature that is somewhere in between outside the home and inside the home. So it will be not exactly as outside, but at least gives you an idea of what the temperature in the garage is. Last year we had the fridge die on us. We smelled smoke, and we looked in the back. There was a relay that was smoking. We caught it before we went to sleep. And then we spent, that was I think November. We spent a couple of weeks without the fridge, and I just put the stuff in the garage. Worked well. Okay, one advantage of living here. But I don't think the sensor would help. I don't want to go through this experience again. Waking up in the morning and going down the stairs in the garage to get the milk and put it on the cereal. Not a good thing. And then I have this sensor HCSR05. It's an ultrasonic distance sensor, which is this guy. You find it on the Eyes of Robot projects, and if you go to the university or anywhere, you find these things. These things are basically a microphone and a speaker. So the speaker would emit sound, and then the microphone would pick it up back and then measure the time in between, and based on that it will give the distance. This is the board, and that blue thing is just a holder so that I can nail it to the garage where it would see if the door is blocking it. So if the door is near, then the garage door is open. If the door is if it measures a couple of meters, then there is no car in the garage, but the door is closed. And if it's something in between, then there is a car in the garage, but the door is closed. So that's the way to use it. And what I did is I soldered. So this is again the ESP32. Okay, so very similar to the ESP8266. But then there is the trusty temperature sensor here, the DHT22. There is a light sensor. The idea is to detect if the light is on in the garage or not. Okay, and then the two doors. Okay. And that's just a board that everything is soldered to, and it took me a lot of time to just get the solder right, and things were moving, and there was no power to these things, and I kept chasing my tail what the stuff. So first rule is to get a multimeter, check the continuity. Get a multimeter with an audible thing for continuity, and just keep checking stuff, and that way you'll save a lot of time. Okay. The other thing is, so these are not specifically microcontrollers, but since I interface my microcontroller to Home Assistant, I use the MQTT, which is a message broker. Basically, it's just a protocol that you put a message in JSON format and say send it to this host, that port, and then there is a message broker sitting there, and the message broker will take it and forward it to the application. Okay. Home Assistant is a Python home automation package, and lots of supported devices. I'll go a little bit in detail later on that. But let me first go through MicroPython and try to show you some of the Okay, so this is the .py stuff. Anyone who knows Python here, raise your hand. Okay, some people don't. I was like you up to a year ago. I had, for something like 15 years, I had on my list of things to do, learn Python. and the opportunity never presented itself until this. So I had to learn it for Home Assistant and for MicroPython, and I love it. It's a nice language. Okay. So let us show you some code here. So it just like imports certain stuff. So import the MQTT, then I have a config, variable stuff, and if I go to the very end, here is the main part of it. Check certain things, okay, and then do the initialization, and then do the main loop, just like any microcontroller would do. And the main loop is here is the main loop. So while true, forever. So just keep doing this stuff forever. Okay. Turn the LED on, and this print will only be shown when you're connecting with the USB, when you're debugging. Otherwise, this print doesn't show. Read the DHT sensor. Celsius is this, humidity is that. Read the distance 1, distance 2, and then turn the LED on, and then send a message for MQTT. So send door 1 distance, door 2 distance, light, Celsius, humidity. And then connect using Wi-Fi, and then send the message using MQTT. And that's all it. Just clean up, publish the message, and that's it. Just display some stuff. So let me plug in the sensor and see what happens.
So Khalid,
Yes.
those functions that you wrote, like send by Wi-Fi and so on, did you write it or did you get a library?
Let's see. It's been a while. Okay, so read lumens is something I wrote, and it set up ADC, analog to digital converter thing. So that's how you interface with that. And then do the ADC read, then sleep for a while, and then do the ADC read, and then return it. So we do it twice just to be sure that the first one sometimes is bogus or something. Read distance is a function that I wrote. So basically, it depends on the library, and I can show you the library. The library basically, if you pass on the temperature, then it will adjust the distance because the speed of sound varies according to humidity and to the temperature.
So there is no driver as such, like it's directly you're interfacing with.
There is, but basically I took something and modified it. So the driver is basically in Python it's an import. It's what you say, import my library, and then you have my library dot do something. My library do something.
Got it.
And then here, this is the reading sensor, so this is the read DHT sensor. Okay. And then the Wi-Fi is probably here to initialize. Here it is. Wi-Fi disconnect is here. Okay. And that's the Wi-Fi connect. Wi-Fi connect is here. So if you look at how many lines there are, it's 270 lines. So not big, with anyone who comes from a programming background knows that this is, very small, and by small it's understandable and it's manageable, So let me connect this guy and see. Okay, first, let's go to the prompt here. What I need to do is to So if I enter this command is basically a terminal, but it will fail because I haven't connected the USB yet. Okay, so that's it. But if I plug this in, so we have lights now, which is good. So this is 115. Okay, So what it's doing here is that if you look at the bottom of the screen, then so it's sleeping for some time and then reading the luminance, which is the light level, the Celsius, the temperature and humidity, and then the distance for one sensor and the distance for the other. And then it says no AP found because it has my own access point, Wi-Fi access point credentials. So it won't work until it's at home. Okay, but then it keeps doing this over and over and over and over. Let's see if I can change the distance on one of them. So just do point one to the. So we had 217 centimeter for one and 13. Now it's 216 and 173. So this looks like 173, right? Okay, now if I do, what is this? 30? Yeah, 28. Okay, so it's working. Now that's not the end of the story because it doesn't say if door is open. It just sends raw data. So on the Home Assistant side, I will have to go and see, okay, so between this and that is closed, and between this and that is something. So there is another programming component. I could put all this inside the MCU, but it's easier for me to test and stuff something that's always connected over the internet and program it rather than a microcontroller that I have to unplug from wherever. So I have to go to the garage and plug it, plug it again into the computer and then go back and plug it where it is. So it's kind of inconvenient to do it that way. So what I'll do here is that, so this is MicroPython, right? So if I press like that, then I get a prompt. Okay? And if I say OS, okay, no. So print, hello. Okay, so it's printing hello. So
Why is it still running?
well, there's something. It's probably because as I said, this is a RISC CPU with lots of ancillary parts. One part is basically the network stack. So probably the network stack is saying that I cannot connect. Okay. So anything you can do not anything you can do in Python. This is a reduced set of Python stuff. So let me exit from here and show you for example, the ultrasonic library. So the ultrasonic library was written by this guy, and then that guy took it over, and then I ported it to the ESP32. Okay. So the idea here is that meters per second at 0 degrees is 331. So speed of sound is 331 meters, 0.2 seconds, when the temperature is 0. So at freezing point. So I pass in, so this is how it works. It says set up so this is just the initialization. Which pin is the trigger pin? Which pin is the echo pin? So there is basically a trigger, so send the sound, and the echo is listen for the echo. Okay? Then distance in inches, just because some countries like Burma and Liberia and the US are still imperial, okay, then we have this inches thing. But actually centimeter is the stuff, and here it's just converting that from centimeter to inches. Basically, I discovered that the first reading is not always accurate, so I just do one reading and jump it. Just not use it for anything, and then do the measure again, and do the measure again, and then do the average of both. So that way you have a more accurate result. And the measuring itself sends a 10 microsecond pulse. Okay, so it sends it puts the pin for the trigger high, and then sends the pulse, and then puts it low, and then checks for the echo. And the time pulse would be the distance basically. Okay. And that's the compensated thing. So basically there is a function, and here is a function, actually this one. So it does the compensation for the Celsius. If you don't pass the temperature, then it assumes you're at 20 degrees. Okay. which is true for here, not all the year though. And then it comes up with the meters, comes up with the distance back. Okay, so it returns the microseconds per centimeter, and that you use that for the. The other stuff is DHT, for example. So let's see DHT. Okay. So that's how you initialize it. You just say what pin you are using. So I use a config file just to make sure that I don't have hard-coded values. So there is a config file that has the pin numbers and things like that. And then here is the reading the DHT sensor. So we assume that the temperature is 0 and the humidity is 5, just as an initialization, and then you read the values. Okay. And if there is an error, then just continue. And then there is validation that they are same values, not like minus 70 as a temperature. That's not possible here, at least. And then return the temperature and humidity. That's it. And
So, Curelet,
yeah.
so there's no operating system or no file system on this thing. So do you actually send down the Python, or is it compiled into like RISC code, assembly code before sent down? How is it?
Okay, so what happens is that you flash it with a file, binary file, using a tool called DSP tool, and this is let me pull up the website.
So once you flash it, how do you debug it? Like just print statements? Or?
Yeah, that's it. I mean, there is no other way because your only access thing is the USB. Well, there is Wi-Fi. I mean, there is something called web REPL, so you can actually have a command prompt over the Wi-Fi. I don't like that because it's kind of scary, because if this is enabled, then anyone can get in. So I just never bother to use this. It's either USB or that's it. And other than that, this device is kind of a send-only device. It doesn't accept data or anything. So even if it gets hacked, then who cares? So there's nothing especially. So let's.
So we're seeing the output here, your print statements.
Yeah, this is exactly what you're saying. You're seeing print statements here. Okay. Because when this is in the garage, it doesn't show this anyway. Okay, but hopefully there will be. Okay, so for example, I flash one light on. It's not visible because. Here it is. See, there's a second light that went on. They are too close to each other, so maybe you won't be able to use it. But it gives me a visual indication. So if I open the garage door and see this flash and go on, then at least this guy is working. If it doesn't flash for I don't know 10 seconds or whatever the cycle is, then something is wrong, and I need to reset it. And there is a reset button on it actually. Okay. Yes.
How do you secure your access point password if it's just flashed on the on EEPROM?
It's basically in plain text on the flash itself, and it's sent using the WAP. So the exchange of the thing is encrypted, WPA2 rather. Okay, so it's using WPA2 protocol from the Raspberry Pi from the router to this device, and vice versa. So WPA2 exchanges its password or credentials over a secure connection. So the password will never be the. The weak point is your router's security. If someone already has access to that, then they have access to this. Okay, but that goes for your laptop and for other stuff. So there is also I can do import OS, and then I can say OS dot. Okay, so if I do a tab, then it will give me what the valid functions are. So if I say list directory, then it will give me the files that are there. So these are the exact same files. You'll see the Let me pull that up a bit here. So there's a boot.py and the main.py. The main.py is the one I wrote. Boot.py just says execute main.py. So it's like the autoexec.bat file on DOS in the old days, or the .profile file. And then there is the variables, the secrets. Secrets is where the passwords are, and then the libraries. And this is when I had that BME 280 sensor that I fried with the soldering iron. Okay.
What does it say if you say os dot name underscore underscore
Underscore what?
underscore name underscore?
These are like defined
Yeah.
kind of variables, not
Just to see if the OS name will be.
Let's see. I don't know. No, it's
There are
like,
dumpers in Python.
like that.
UOS.
Okay. But then if I say okay, list directory, and I want to list this directory. So this library has this, so I can say lib umqtt. Okay, so there is a simple py. So basically, this is the MQTT library, and it's when I installed it, it goes into that directory. Okay. There are lots of things you can do. For example, if I say print, okay, and I'll say time. Okay, so this is the number of milliseconds since the MCU was powered on. Again, it doesn't have the concept of date or time because it doesn't have an operating system, it doesn't have a real-time clock. I think it does have a real-time clock, okay, but I'm not using it, or I'm not sure if MicroPython can use it. Yeah, it has a local time, so let's see what the local time is. So again, time is basically a library. Okay, so it has never been set. It's the default on what it is.
Is MicroPython technically a microkernel, or?
I don't know what you call it, but basically it's I don't think it's a microkernel because it doesn't have like the multitasking capability or any of that. It's basically, it has a file system, but it's what you've seen. Okay, so it takes the flash part of it and makes it into that, so that when you store stuff in it, so when you send the program, so it doesn't have scheduling, multitasking, managing storage or stuff like that. It just deals with pins, and that's it.
So you're saying MicroPython is the operating system?
Sort of. You can call it an operating system. Calling an operating system would would be too glorified
Okay.
for what it does. It's actually a hybrid. So instead of flashing it with a program in Arduino, what they did is that they took MicroPython, stripped down everything, and then they produced the flashable image and they put that in. And then they allowed you through the USB to interface with it.
Yeah, so the driver for USB, for example, will be built into this thing, or is that something that you have to load before?
I think the driver for the USB is a chip on the
Okay.
in here. So there would be something called either a CP2102 or there are like three. You remember FTDI? So FTDI is a company that made the serial chips, and they I think a few years ago they did a bad thing where if they detected a non-genuine chip, because China started making counterfeit chips, they would break the device. And that was basically, it's not the fault of the user. If I buy a chip, I don't know if it's counterfeit or not. But why break my device? Go and take your fight with whoever is doing the chips, not the end user. So they backed off and all that. So there are other companies that don't have these things. One of them is CP2102, which I use for another project, which I'll show you later. And there's a third one that the name eludes me, but you can buy these as a separate add-ons, or they are sometimes embedded into such devices. For example, the STM32 has its own, has one of these devices as well to manage the USB. Okay? And it's basically just a UART. So UART is basically a universal asynchronous, what is it?
Receiver
transmitter. Okay, and there is the UART, and then it takes the transmit receive and gets out a CTS and DTS and stuff like that. If I say time.sleep for 2. Okay, so it slept for 2 seconds and that's it. So if I do it for 5 seconds, let's count 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, there. Okay, came back. So, and then you can also say sleep milliseconds. So I will sleep 5,000 milliseconds, which is 5 seconds, same thing. Okay, someone counts. 1, 2, 3, 4. Okay, so it's back. So you can time things like that, like you initialize the device and you have to wait for a while, okay, and do stuff. So that's why you see in somewhere in the code there, sleep for 20 milliseconds after you do certain things. Or if you want to send the pulse in the distance sensor, then you send the pulse and then you wait for 10 milliseconds, 10 microseconds rather. So there is this stuff. So there's a whole bunch of so if I say import, so these are the stuff that I can import. So GC is garbage collection, debug, I have never used. Machine. And then if I say machine is basically MicroPython's abstraction layer of the hardware. And the hardware in this case is a microcontroller with just a few ancillary chips. So you can do these things like deep sleep. So for my other sensor here, which also runs MicroPython, I don't need to measure for the garage door, I need to measure it every 10 seconds or so. Because, it takes about 10 seconds for the cover to go up and then for the door to go down. But then I need to know as soon as possible if the status changes. But then for reading the temperature, the temperature doesn't change in 1 minute that much. So I said, let's add a deep sleep thing here. And deep sleep here says, turn off the microcontroller altogether. But then there is something inside it, like a alarm clock that would say, wake up after 60 seconds. And one of these wires here enables that functionality. So some of the microcontrollers would require this wiring, some won't. The other one doesn't. So I can do this. But for this one, I have to wire this thing. The other wires are just for the temperature sensor.